All right, Advent of Code 2022, day 4. Let's get started. Big list of section assignments for each pair. For example, consider the following: 2 sets of numbers divided by a dash with comma. First pairs, it means within the first pair of elves, the first elf was assigned sections 2 through 4. Sections 2, 3, and 4, while the second elf was assigned 6, 7, and 8. The elves in the second pair were assigned 2 sections. The elves in the third pair were each assigned 3 sections. One got section 5, 6, and 7, while the other got 7, 8, and 9. The example list uses single-digit section IDs to make it easier to draw. Your actual list might contain large numbers. Visually, these pairs of section assignments look like this. Okay, some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 through 8 fully contains 3 through 7, and 6 through 6 is fully contained by 4 through 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning set, blah, blah, blah. How many assignment pairs does one range fully contain the other? Ugh, that does not sound fun. Okay, day 4, challenge. Go ahead and run this, see some output here. I don't have any sample data. This is the sample data. Although the sample data today does not look like the input, so. Interesting. There are 2 pairs. Okay, they've been assigned a job. Every section has a unique ID number, and each elf is assigned a range of section IDs. They've noticed that many of these assignments overlap. To try quickly find the overlaps and reduce duplicated effort, the elves pair up and make a big list. For the first few pairs, this list means within the first pair of elves, okay, this is a pair of elves, I guess. The first elf was assigned sections 2 through 4. While the second elf was assigned 6 through 8. So we've got pairs of elves split by comma. The elves in the second pair were each assigned 2 sections. The elves in the third pair were each assigned... Yep. So how many of these are within each other? Right, so... one of their assignments fully contains the other. For example, 2 through 8, right here, the fourth one down, contains 3 through 7 and 6 through 6. Okay. Is fully contained in pairs where one assignment fully contains the other. One elf in the pair would be exclusively cleaning sections that their partner will already be cleaning. So these seem like the most in need of reconsideration. In the example, there are 2 such pairs. In how many assignment pairs does one range fully contain the other? Oh, so... what's the best way to build this? We could build a list and check max mins. We could... In fact, that's what I'm thinking we're going to do. So pair 1 is going to equal item split on the elves is going to equal item split on the comma. Pair 1 is going to be elves 1, 0, and like this, right? And then we can print pair 1, and so we just get the first set. Okay, so we've got that, and then we could say, like, we could build maybe tuples. So we could say, pair 1 max is going to equal, I don't know, could we literally just say, let's look at what our actual input looks like. didn't get the input today. I'll have to fix my script. Okay. Okay, so it does actually look like what was suggested. I don't know why they're breaking it out into more. Okay, so what we could do here is we could say we want just the very first, right? The first thing. And that's actually going to be the min. Are these always smallest to largest? Let's look. 2093, 2090. Yes, they are always that way. So we could similarly do this, right? This would be the max. I don't love this, but oh. I just want the, is it -1? There we go. Oh, geez. Okay, so we can do this. Then we can grab the min-max of pair number 2. Okay, so we've got this broken up now. So now we need to see which of all of the things are contained within each other. So we need a comparison of all of them. Right, so we can do let's see. What do they call this? Overlapping is going to equal 0, right? And if we get one that overlaps, then we're going to add to it as a count. Then we're going to print the count out at the very end. So we could say something like, if pair 1 min, that's a lot of data to check. That's a ton of data. We could do 2 for loops here. For item in Okay, yeah, we could do min-max pairs. We could build a new list. New is going to be this. We're going to do new.append a tuple of pair 1 min and pair 1 max. And here we can do pair 2, right? And then at the very end, we're going to print new. Okay, we've got a list of tuples here, and then we're going to do another for loop for pair in new. Going to print pair, and if we wanted, for instance, just the mins. Perfect. So this min, I can't use min pair is gonna equal pair. I'm being a little too verbose here, but I don't want to get confused. Okay, so now what we can do is we can say if if oh my goodness. Basically, if these need to be integers. Actually, these need to be integers. How do we check this correctly? We want to make sure that 2 is greater than the next one. And 4 is less than another one. We really want another for loop here. For check in new. Ugh. We're going to say if the min pair of the first set is less than check of 0 and the max pair of check 0 is less than if the max pair is less than, right, if they're in between, then we're going to take this overlapping and we're going to do it here. And at the very end, we're going to print overlapping, and we should get a 2. And somewhere in here, check int. And this needs to be the index of 1. Not supported between string and int. What these? Let's just wrap everything just in case. We get 1, okay. Okay, we needed 2 based on this. So if the minimum pair is less than 6, for instance, or if 6 rather is greater than 2. No, which ones are the ones that match? Let's find a correct one here. So we got 6 through 8. Okay, 2 through 8 is the one that they gave. Yep. Fully qualifies 3 through 7 and 6 through 6, right? So the 3 and 7 pair, if 3 oh yeah, some of these are still strings. Where did I mess up? We're adding int, new for pair. These are integers. These are ints, these are ints. These are ints. What? Pair to min. Oh, right here. Yep. I forgot these 2. That's too bad. Okay, so hopefully. It's still a 1. Let's just print the pair here, right? Can we do that? Oh. Why is it printing all of them? But plus equals, how did I accidentally? We have 37, so that's definitely not right. Okay. So that's some plus equals stuff. Okay. So basically, if 2 less than or equals maybe will help clean up a little bit. That's not going to fix it. Oh, that's going to double it. Perfect. And not, let's see, and new index doesn't equal, right, check, I think. Invalid syntax, and I got 0. Because we want to exclude the same one, right? We want to skip over. 2 inside of 4 should not be 2 inside of 4. We want to skip it. let's print new index and check to make sure that they're different. Let's cut this out temporarily. Let's print it. These are not matching up. They should be. Okay, those ones match. A few of these match, and then it starts to get. Oh no, they all match. Okay, so why didn't that work? Because these will always. We basically want to exclude the current one we're on. Maybe we want pair instead of check. 54, not quite. Maybe we just want check. No, it's ultimately the same thing. We're super close. If we can fix this index issue, I think we've got it. Okay, so this is going to take 2 and 4. Yeah, okay. So we've got a pair. We need to check that one. We don't want these matching up, basically. Check pair. There we go. Okay, I was printing out the wrong thing. So these don't match, which is good, but so now this logic somewhere right in here is incorrect, and we don't technically need to enumerate anymore, and we can get rid of this. So if the min, curious, does that doesn't fix it. That's questionable still. So we want the min pair to be less than or equal to, do we want them flipped? Because we're checking inside. No. We want the min pair to be rather, we want the next pair to be greater than. No, we do want this to be greater than or equal to, because it's contained within this as the lower, and we want the max pair to be less than or equal to this one. And we want to have the pair, and we're checking it if it's inside of this. So let's debug this. Is 2 and 4 inside of 2 and 8? Yes. Is 2 and 4 inside of 2 and 6? Yes. And then this one breaks. Which are the two that should work? For example, 2 through 8 fully contains 3 and 7 and 6 and 6. Oh, we need to break here. Oh, jeez. We need to break. That's getting much closer. And then now we need to fix these. Right, because we want to break out of the first loop. Start over. This is the check. Yep, okay. So do we now want this back? Not quite. Do we want the equal signs? That doesn't matter at this point. Okay, this is the one that's in the story problem, as is 6 and 6 is not in here as far as it relates to 2 and 8. It's got 5 and 7, so something's still wrong here. Let's go back and read real fast. They've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of section assignments. For the first few pairs, fully contains the other. Fully contains 3, 6. Oh, right there. For example, 2 through 8 fully contains 3 through 7, and 6 through 6 is fully contained. Oh. Interesting. Because it's just a 6, and it's less than or equal to the max, so we definitely need the equal signs. So what we're really saying here is, wow. Okay, so we want the min pair, which, let's take the 6 and 6, for example. We want the min pair 6 to be greater than or equal to 4. And we want the max pair 6 to be less than or equal to 6. That's correct. And we don't want them to be checked against each other. And then we break. We rinse and repeat. I've got something out of order. Got something out of order here. Let's go ahead and see what's up. Oops. So if we printed all the pairs, let's get rid of this. Interesting. What? They should just be. That is oddly suspicious. Why am I getting 2 and then sometimes 1? I don't have any other prints in here, do I? Oh, I do. Okay. Okay. So here's my individual pairs. Do we need to be... Oh, let's double check. 6 through 6. 3 and 7 is... Oh, we need to be comparing just... Not the whole set, but pairs. Oh. So we... Oh, man. This is way less complicated than I think it needed to be. We just need to be comparing... Ooh. I think new 2 equals this, right? This is going to be new 1. This is going to be new 2. For pair and new 1, kind of yoink this. And then we need for check in new 2, pretty much. If the min pair think I'm probably just copying the same stuff. Break, print, overlapping. Oh no, that was it. I made it way more complicated than it probably needed to be. 973. Let's try it, see what happens. No, not correct, not correct. Okay, interesting. So we got a 2 here. Let's go ahead and swap back to the sample data. And let's print the pair against the check. Ooh. That is not what the problem gave. Right, 2 and 8 fully contains 3 and 7. Do we need to swap this? No. Oh, we're doing it. I'm literally doing it again. We don't even need this. We need, well, we need something probably like this. And what we're going to say instead is, we're going to have this check here. If the min pair is new to index of 0, I think is what we need. And new to index doesn't equal pair, print the new to index, overlapping break. Okay, we do have this. That's one of the 2 that we need, so why didn't it get the rest of them? We don't need this break. Oh, okay, that still doesn't help. What if we just printed pair and then new to index, just to make sure we're getting the right mappings together? 2, 4, 6, 8. 2, 4, 6, 8. Yeah, okay, so we are getting the right mappings. We just have the wrong math. Does that matter? It doesn't matter. And frankly, this is not a thing anymore. So if I guess it could be the opposite of this too, right? You're checking for overlapping between either, or it's the inverse, I think. That gives us 2, 3, 7, 2, 8. That's it. Okay. Input. Let's try this again. We get 738. Still not right. The sample data gives us all the correct data. So what are we missing here? What are we not thinking of? Three and 7 is contained within 2 and 8. 6 and 6 is contained within 4 and 6. That gets us 2. This should be all the correct math. Obviously, something in the input data. So what we can do is we can actually swap this back to input, see our debug info here. Wait a second. Some of these numbers were double digits. Oh my goodness. I'm doing this dumb thing here where I'm grabbing up until That's too bad. This is going to be split on the dash, and we're gonna take the first, and same with this. Split on the dash, and we're gonna take the second. Yep. Wow. Because this doesn't account for those double digits. This was a really dumb way of doing this. Don't ever do what I just did here, 496. There we go. We've got double digits in there now. Yep. Oh my. Made that way more complicated than it needed to be. Okay, there's still quite a bit of duplicate work. Overlap at all. The elves would like to know the number of elves that... Oh, see, this is... I was doing part 2 for part 1. In the above example, the first 2 pairs don't overlap, while the remaining 4 pairs do. Maybe not. 5, 7, 7, 9 overlaps on a single section 7. 2, 8, 3, 7 overlaps all of the sections 3 through 7. Oh, they want to sum. Oh no, I'm going to have to fix it again too, because I'm only accounting for max and mins, not all the individual numbers. So in the example, the number of overlapping assignment pairs is 4. Single section. Oh, maybe not. Overlaps on a single section 6. Overlaps on sections 4, 5, and 6. I don't know how this is any different from part 1, actually. Instead, the elves would like to know the number of pairs that overlap at all. Oh, so not this min-max stuff, I think. Just, is there... Oh, okay. So this is part 1, and then probably down here we're going to do part 2. I'm going to yank this. We're going to get rid of these extra prints. We're going to say overlapping part 1 plus equals, what do you want from me? Overlapping part 1, because we need to use it. What's wrong? Indent, okay. Part 1, and then we've got overlapping part 2. And get rid of this for now, I think. Overlapping part 2, part 1, we're gonna do this. Okay, so for here, instead of the max min, we just want to know how can we do this, because we're only accounting for max and min. I cut a corner up here and we're not doing all the individual numbers. So what we could do is we could take the min. It says 4 for the sample data. So we need to get a 4 out of this. We've got a 2 right now. We need to get a 4 out of it. We can do so by saying something like... I'm not sure the best approach here. Overlaps on a 7. Because we're only going to have these... We basically want to know, actually... Okay, we can check the 2 ends here, I think, right? We can simplify this a bit and say something like, if the min pair 5 I don't even think we need an and. I think we can do this. We get a 6, right? Because we want to see, is 5 less than or equal to 9? If it does, we add it. Because that's an overlap, right? If maybe we need one more, and the max pair is greater than or equal to new to index of 0, maybe? Yes. Come on, that would be awesome if this worked. 847. Perfect. Okay, so let's go look at what we did here. And clean this up a little bit here too. Answer 2. Okay. So we have pair of elves split by commas. This is a pair of elves, elf number 1, elf number 2. They're doing cleaning in these sections. We wanted to know where the overlap is and how many assignment pairs does one range fully contain the other, right? So we wanted to see which one is inside of the other. So we set it to 0. We're going to iterate over everything. We're going to split the elves by comma, right, to get the pairs first. So we're splitting 2 through 4 from 6 through 8. Then we are splitting those by a dash to get the min and max number. This is an approach. There's lots to this problem. I felt that the in-between numbers were not important, so that's why I went this route, is I just totally skipped them. It's better and easier to deal with a min and a max number than it is all of the sets of numbers in between these ranges. And fortunately, I was dumb, and I should have just split it like this, because this doesn't account for double digits. And I got burned by that. So then we're appending it to a new list so that it's easy to deal with, and we're using tuples here. And then we're going through that list. We're saying if the minimum number, the minimum pair, is greater or equal to the next one, and the max right here is less than or equal to this one, then this is inside of that one. On the flip side, we wanted to check that the right-hand side was contained in the left-hand side, right? So both left and right pairs of elves could be contained within each other. Check for both. And then we add 1 to that, and that's the number. For part 2, it wanted to know, it didn't care about which one is in each other. It wanted to know if it overlapped whatsoever. And so we could vastly simplify this by saying, hey, if the smallest number here, where's part 2? If 5 was less than 9, we knew that these numbers were certainly, basically, it's a possibility, right? If the first pair is less than the second pair, then there is potential for overlap. The only other thing we had to check to qualify it was making sure that the max pair of pair 1 was at least greater than or equal to the second set of this, because that would qualify overlap. And so that gave us that number. And then we return it, and that's pretty much it. Let's print. Let's find the extra prints here. Get rid of this none. And we need to return this instead. This should now print it 1 per line. Perfect. Let's punch this into our test suite. Day 4. 496. And 847. We'll run that. and we should be good to go. If you enjoyed this content, would love for you to subscribe, to like, to share, all those good things. This was Advent of Code 2022, day 4. Catch me tomorrow for day 5.